Hi everyone, welcome to our lab. Today we will look into impedance spectrometry. It is this little machine that you can see here with the blue edges. We use a Gambling machine. It might be smaller than what you have imagined. Impedance machines can also be a lot bigger, but for most common measurements that we do in the lab, this small machine is good enough. And what I want to show you today is a measurement. And I want it to be also a perfect measurement. So for that I use this board. This is an example that I created. I borrowed this from Erik. And I think this beautifully can illustrate a circuit, an actual circuit. So here I have made something with a battery. Here I have a switch. And here I have a propeller. And that also gives light. So what I can do is everything is connected to the batteries. And then I just push it to on, and then it makes sound, and it goes around, and it makes light. And then if I, for instance, break the circuit here, then it doesn't work anymore. And then if I put it back on, it works again. So I think this beautifully can illustrate something that we know from paper, so you can exactly copy this on paper and it will look the same. And today I want to do an impedance measurement with this circuit that I created that has a resistor and a capacitor. The resistor is 1 kilo ohm, 1000 ohm, and the capacitor is 100 microfarad. And they are in parallel, and this is the RC circuit that you know from the theory. And it is really also the wobbly line and all the signs are the same as you would have drawn them down. So I'm going to connect that to the impedance spectrometer. And the impedance spectrometer has all these little wires here. And here you can see how that the different setups that we can choose. So we can have a 2 electrode, 3 electrode, and a 4 electrode. The most simple one is the 2 electrode that we are going to use, where we will have the working and the working sense on one side, and the counter and the reference on the other side. So I'm going to connect that. It's a little finicky, so I connect that on one side. And the counter and the reference go on the other side. It is very important when you do these measurements that the wires and all the metal clips are not touching the wrong things, because it's a very common problem that they do, and then your whole system short circuits and then it doesn't work anymore. So now the whole system is connected in a 2 electrode setup to our Gamry impedance spectrometer, and now we will start the measurement. And I want to look at the Nyquist plot. Because we have an RC circuit, we should get a perfect semicircle. And the scales of the axes change during the experiment. So at the beginning it might look a little messy. But what we should get at the end is a semicircle where the top is around 500 ohms. And where it then touches the horizontal axis, it should be around 1000 ohms. Because that's how an RC circuit works. Because normally you measure then a battery, and then you don't really know the resistors and everything. Now we know it. But something you can see immediately when we have done the experiment is that when the semicircle touches the horizontal axis again, that should give the resistance of the resistor, which in our case is 1000 ohm, 1 kilo ohm. So let's see whether we really get there. Here you can also see the different frequencies we are currently measuring. And the lower the frequency, the longer the measurement takes, because it's just harder to do. And if you really want to measure at a very low frequency, then you will need the more expensive, bigger machines. So as you can see, we have approached 1000. You can see we are almost at 0 again. So we have proven that the resistor is really 1000 ohm. So they are not lying. So that's nice. So normally you would use the EIS for measuring full batteries. That can be coin cells, lab cells, pouch cells, cylinders. But you can also measure materials, cathode, anode materials. You will need a more specialized setup for that. You need to then make a coating, and then you need to find your special setup for your material. And personally, I really like that, because if you do that correctly, you can really find all the different resistances that are available in your material. And we are also currently doing that at the moment for our own research. So this is EIS, so thank you very much.